Okay, back at it. Let's get back to this problem here. We get this 5 kilogram mass that's at rest on a ramp at 37 degrees. We need to figure out the force of friction. But the key thing is on a ramp, we are going to rotate our axes. Our axes are going to be rotated. Our x-axis is going to be along the ramp. This angle here, 37 degrees from horizontal. That's going to be our x-axis. So the force of friction is along the x-axis. The normal force is going to be along our y-axis. Our y-axis is not straight up and down anymore, not totally vertical. Our y-axis is going to be perpendicular to the ramp, into and out of the ramp. Okay? And now the force of gravity is a little weird. So let's look at that closely. So here we go. We've got the force of friction up this way, the normal force perpendicular to it, and the weight is straight down. We know the weight is 49 newtons, and we know the weight is at an angle of 37 degrees from our y-axis here. Some of that, we're going to take that 37, we're going to turn it into a right triangle. Some of that 49 newtons, some of that 49 is this way, and some of that 49, oops, hard to draw. Some of that 49 is this way. Right? Some of it is opposing. Let's see, might be better to draw it. Some of that is in that direction, some of that is in that direction. We're going to break this into its two pieces. I typically draw it there. So that piece and that piece are the same arrow, right? The force of friction, if I go sum of the forces in the x, we'll call up the ramp positive. Force of friction plus this part. This part is opposite 37, Fg multiplied by the sine of 37. Opposite side is sine. SOHCAHTOA. Opposite is sine. 37 degrees. And again, since all of this is down the ramp, we'll call it negative. But let's say so 49 multiplied by the sine of 37 degrees is basically 29.5. Basically 29.5. We can go with that. Yeah. So we've got sum of the forces in the x direction equals the force of friction minus, again, because down the ramp is negative, 29.5 newtons. The sum of the forces is not moving up or down the ramp, so 0 equals the force of friction minus 29.5 newtons. And what minus 29.5 equals 0? The force of friction equals 29.5 newtons. All right, so there's our first part of the problem. Let's see what we got here. Determine the force of friction. We got that one. Now the normal force. The normal force will be the sum of the forces in the y direction. Sum of the forces in the y direction. Our y direction is going to be our normal force plus this part. This part over here of our weight. It's not all 49 newtons. It's only the adjacent side, right? Remember your trigonometry. This was the opposite side. Here's the adjacent side. Here's the hypotenuse, and here's our right triangle, right? Hypotenuse, adjacent, opposite. The normal force is going to be equal and opposite to the adjacent side. The adjacent side is going to be the weight multiplied by the cosine of 37 degrees. And again, we'll call it into the ramp as negative. This is going to be positive, out of the ramp, into the ramp. We'll call this negative. There's our frame of reference. Everything up is positive, everything down is negative. Everything up the ramp is positive, everything down the ramp is negative. Out of the ramp, positive, into the ramp, negative. So 49 times the cosine 37, 39.1. So again, it's not moving, so the sum of forces is 0. The normal force, the support force, minus 39.1 newtons. What minus 39.1 equals 0? The normal force is 39.1 newtons. That's our other part there. Really quick, we want to solve this coefficient of static friction. The coefficient of static friction is very simple. Repetitive now. Mu times the normal force. Force of friction is 29.5. Mu is 39.1. We want mu by itself. Whatever you do to this side of the equation, you got to do that side of the equation to get mu by itself. Divide this side by 39.1 newtons. Divide this side by 39.1 newtons. Those will cancel out. You get 29.5 divided by 39.1, 0.75. Mu is equal to 0.75. Key thing there, notice all the units cancel out. Newtons divided by newtons goes to 1. That becomes 0.75 equals mu. And that is how we solve all of it. Done. Good luck on the practice problems.